Okay, so this is a quick little introduction on lab number 1. It's on simple harmonic motion, and essentially it'll be taking a mass on a spring and allowing this thing to go up and down about its equilibrium position. So what you're going to do is you're going to first make some preliminary predictions, and bear in mind that I don't grade your predictions on whether you're right or wrong, but more that you actually did them. So predict the position versus time and the velocity versus time. You go ahead and you open up this lab, and it's going to bring up something that looks kind of like this. Click the begin button, and what we can kind of do is we can mess around with some things. We can mess around with the spring constant, which is how springy this spring is. We can mess around with the mass, and we can mess around with the amplitude. And what I really want you to do is set some parameters. They're in the table. I'll go back to it. And what you're going to do is you're going to see which parameters affect the frequency or the period of this thing's motion. So you're going to hit the collect button. You kind of see the mass on the spring going up and down, and you can kind of see the position versus time graph. It looks a whole awful lot like a sinusoid. And what you're going to do is you're going to identify the period, and that's going to be the time for one full up or one full down. So what you can do is kind of pick the maximum values and say this right here is one full period with a capital T. And so what we would do is you're going to say, okay, well, this is half a second, so 0.1, 0.2, 0.3, and so on and so forth. So I might say that this value right here is 0.21 seconds, and this value right here, let's just for the sake of argument say this is 0.66 seconds. I can take the difference, and that's going to give me my period. So let's go ahead and pop back to the lab very quickly, and what we could do is we could say, okay, well, I've gone ahead and I have set up my lab as such. I've adjusted my spring constant, I've adjusted my mass, and I've adjusted my amplitude. This period is just going to be the difference between the maximum value and the maximum value, or the minimum and the minimum, totally up to you. And then we can calculate the frequency. I'll do an example calculation in just a little bit, but let's come on down to the analysis, and what you can kind of see is what we're trying to figure out is what is going to affect the frequency. Does it depend on the amplitude of the motion? Does it depend on the mass used? And does it depend on the spring constant? So what we can kind of come back up here and see is here I have some spring constant, some mass, and some amplitude. All I'm going to have you do is do 6 different runs. This one right here is going to change the amplitude. This one's going to change the spring constant, and this one's going to change the mass, leave the spring constant the same, and this one's going to change the spring constant and use the same 2 masses that we kind of used. So what we can kind of do is let's just do a quick little calculation here of the period. So I said that beforehand that my period was going to be the difference of the times that I measured. And so I said my time was 0.66 seconds. And I said that my initial time was 0.21 seconds. And you go ahead and you take the difference, and we're going to find out the period is 0.45 seconds. That's what you're going to put into the table. And then you're going to say that the frequency is just 1 divided by the period, and you go ahead and you type that into your calculator, and you're going to find out that it's 2.22 hertz. So that's going to go into the table as well. Then all you have to do is to do those 6 different runs, calculate the frequency, and see what is going to affect the frequency.